When you look at a structure that seems to be standing in water, what comes to your mind? What do you think happened? How did they build it? Because the river was there. So today we are going to be covering how does engineers actually construct those kind of structures that seem to be they are floating or standing in water. This is Pilasande speaking, and I welcome you to P.EXPLAINED channel, where we explain the engineering behind the things that we see and experience every day. A quick note for me is that P.EXPLAINED channel is a channel that is built on established engineering principles and standards. And so I'm here to teach and simplify, not to claim the work as my original work, rather refer on the engineering standards and principles. So the question lies, what is under the water? The first thing we see is the water, but underneath, it's actually what really matters to an engineer: the ground. There may be layers of sediments, clay, sand, or eventually stronger material or rock, each with different kinds of strengths, but those structures may be visible above the water. The real issue is the foundation because it depends entirely on what is happening underneath. Now, this is where the site investigations come into place. And this is exactly where surveys establish the water depth and under profile waters. Boreholes, they also do their own testing and they reveal the soil structures and the conditions. Engineers need to know how deep the water is, what the soil layers are, and how the ground will behave under loading. Now, the plan will be to plan, investigate, understand, and design. And that is the process of the site's investigation. Now, the foundation design depends entirely on what is discovered below the surface. So, how do you work in water? That's a very good question, and that is someone that will be thinking about it. Because we see the structure standing in water, but we don't know how they are actually constructed. Now, sit tight and listen carefully. So, it starts from step one, the site preparation. So, what do we mean by this? Even once the ground is understood, there is still a problem of actually how are we going to build in water? You can't just put the workers or equipment into the river. Engineers need a safe access and a controlled conditions, often using temporary works like cofferdams, causeways, and barges. But these may be part of the final structure, but they are very, very essential. Now, cofferdam is a kind of a structure that is a temporary enclosure that will be built around a working area. The sheet piles are used as a barrier, and the water that is inside is then pumped out strategically, creating a controlled dry space. So, when you see workers building a bridge pier, they are often not standing in flowing water, rather, they are inside engineered dried space. So, welcome to the pile foundation, where we introduce the main reason you see the structures that look like they are actually floating or standing in water. Now, pile foundations are the most part of this because since the upper soil layers may be too weak, engineers take the foundation deeper using the piles, longer elements that transfer load into the ground. They are installed by driving or drilling. So when you see a structure that is above the water, it's not only the part of the foundation story, but it's what actually lies deep underneath. So how does a pile foundation transfer the load? A pile transfers the load in two ways. There is a skin friction way where the soil is along its surface and that is helping it to resist the load. And then the second way is the end bearing. This is where the load passes through the tip of the strong material and right underneath. A pile isn't just a buried column. It's part of a carefully designed load transfer system. So someone will be saying, what is the difference between a pile group and a pile cap? So, one pile is often not enough for a large load, right? So, engineers need to come up with a plan. Engineers group several piles together and they are connected by a pile cap. So, the methodology will be structure, pile cap, then piles, and then the ground. So, let's talk about the loading part. So now we're going to analyze how the load happens or how the loading happens on this kind of structures. The process will be deck, from the deck to the bearing, from the bearing to the pier, from the pier to the pile cap, to the pile cap, then piles, then from the piles to the ground. So now that we've grouped the piles together and then we named them the group pile, then we connected them into the pile cap, then now they are stable. Let's analyze how does the loading happens on these kind of structures. Now, picture a vehicle crossing a bridge. Its load travels through the deck, and then from the deck to the bearings, from the bearings into the pier, then down to the pile cap, then from the pile cap into the piles, then the piles directly transfer that load into the ground. Now, a structure doesn't just stand. There are forces that travel through a continuous system and they travel all the way down. Now, building the pier and the superstructure. Constructions follow the same path upward. We start from the pile and to the pile cap, then pier, pier cap, bearings, and finally the deck. Now, this connects to our last video where we were talking about the expansion joints and the bearings. Now, those two components, they play a very crucial role in the whole system. And this is how we safely transfer the load to the ground while it's also dealing with its own surrounding water. Now, have you ever heard of a term offshore platform? Most of the movies will see some kind of a gigantic structure standing in the middle of the ocean. It looked like a house. It looked like it's floating, but it's not. It can look like a building or it look like a machinery, but it's not. Actually, it's not floating. There is a critical and a technical method of constructing these kind of structures. And that is where also pile foundation is introduced. Now, let's take this further. An oil or a gas platform has facilities above the water, but a supporting jacket structure is right below. A foundation of piles is actually anchoring into the seabed, supporting this gigantic structure that keeps working the whole of its period. Now, what about the environmental loads? Now, marine structures also have to resist their own movements. Those kind of movements can be caused by wind, waves, currents, and vessel impacts. So, engineers have to think of another plan now. They can't just say, can this kind of a structure carry its own weight? But they also have to ask the question to say, can it survive the environment when the environment is actually pushing against this particular structure? And that is where we introduce those terms that are such as the scour, of which is the hidden danger, the danger that happens away from the people's eyes. Now, flowing water can erode the ground around the foundation, but over time, it can expose the whole foundation more than it is designed. And then the engineers have to make a plan to protect this. So now, the construction above water. Once the foundation is ready, construction continues above the water formwork, reinforcement, concrete, and steelwork. But remember, what we see above is only the visible part, but more of the engineering happens right below. So the complete load part will be bringing it together. Load travel from the deck through bearings and piers into the caps, into the piles, down to the piles, then into the ground. While the whole system also resists wind, waves, currents, vessel impact, or scour, what looks like a single concrete pier from a surface actually represents an entire chain of engineering decisions extending all the way down into the ground. So next time when you see a structure standing in water, remember you are only seeing what is above the surface. So next time when you see a structure standing in water or looks like it's floating in the water but it's not, just think of a pile system, a pile foundation, a kind of an engineering technique that actually allows the structures to stand in a most impossible position or location that no one have ever thought of. But we still have those kind of structures and they serve really good. Welcome to civil engineering. So I thank you so much for watching this video and I hope you learned something that is much valuable and very important. And I urge you to please like and subscribe. Share the link to others. They would like to know what we see every day but don't have the clue of what is actually going on.